For number one, what do we do in number one? John.
A squared plus B squared equals C squared.
Yay, what is that called? Yeah, buddy. So a squared in this case, we're going to make what?
R2
Okay, so r squared plus
12, 2 equals 13.
Okay, why did the 13 have to be the C? Very good, and it's also the hypotenuse. Excellent. So when we square these, we should get r squared plus 144 equals 169. Then what do I do? Subtract the 144. Very good, John. What do I get?
You get 25.
25 equals r squared. Then what do I do? Square root of both sides, and we get r equals 5. Hey-yo. How many of us got that 5? Raise your hands. Yay. If we didn't, what questions do we have? Talk to me. We're Gucci? All right. The second one. Hannah? Yes, it is. Why is it a 45, 45, 90, Hannah?
It's isosceles, and the one angle is 90, so the two base angles must be 45.
Excellent. It's an isosceles triangle.
As to how I don't remember how to get it.
You don't remember it? Dylan, do you remember? You did it a totally different way, and we will get to that way, and I'm glad that you said that. Sophia? You did it the other way? Did you do r squared plus r squared equals 18 squared? Okay, good. Did anyone do it the 45, 45, 90 way? Okay, then write this way down as well as the way that you did it. So, because it's a 45, 45, 90, that makes each of the legs, we're going to make them little a's. Do you guys remember that? Little a, and the hypotenuse is little a times the square root of 2. Now, let's solve, because they gave us the hypotenuse was 18. Let's solve for little a and the hypotenuse, right? How would you solve for little a and the hypotenuse? What's that? No. So we want to solve this equation. Like, let's solve this equation for a. What would we have to do to solve this equation for a, guys? Who said divide? Good one. We divide by what? Very good. Divide by the square root of 2. So now in your calculators, plug in 18. Can you do it for me? 18 divided by the square root of 2. German, you're going to be my calculator person for today. Yeah? Yeah. Mm-hmm. And click enter. 12.7. A equals 12.7. All right, now, there was another way to do this problem. Dylan, can you walk me through what you did?
18 times 18, I forgot what it's called.
Squared? Mm-hmm.
You get 324 divided by 2, and then you square root.
Oh, so you divided it by 2 and then you took the square root of it?
Yeah.
Perfect. Okay, but let's see why we're able to do that. 18 squared, just as my hypotenuse, should be equal to r squared plus r squared, my a and my b, right, in my triangle. R squared plus r squared is 2r squared. Then we divide by 2, like you said. What did you get here, 122 or 162?
Yeah, 162.
162 equals this, or r squared. And then we take the square root of both sides, and you got 12.7 equals r, okay? You'll get the exact same answer regardless how you do it, okay? But this is how you get both answers either way. What questions do we have on the second example? So 11.1 is all about circumference and arc length. How many of us have heard the word circumference before? Does anyone know what it means? Hannah? Very good. It's the distance around a circle. So before we talked about the degrees around a circle. How many degrees are in a circle? 360 degrees. But guys, circumference is not degrees. Circumference is length. So like, yeah, it takes like 360 degrees to go around a circle, but how many inches is that? How many feet is that, right? We're actually going to be calculating the total distance around a circle. So circumference and degrees are different. Now, arc length, when have we heard the word arc before? In the last chapter, right? What did arc represent? What was an arc? Yeah, it was the edge, but was it the whole circle? No, it was a piece of the circle. So now an arc length is going to be a piece not of the 360, but of the circumference, okay? So it's going to be the length of the arc, the actual physical length in inches, meters, feet, whatever units, it's going to be the distance of an arc, okay? All right, so, ooh boy. All right, so the circumference of a circle. There's two formulas for the circumference of a circle, okay? And circumference, as we just talked about, is the distance all around the circle. Now, the circumference of a circle can either be written as C equals pi times D. Who thinks they know? Remember, this is for circles. What D represents? Diameter. Very good, okay? It is a form of distance, whoever said distance, okay? You're not wrong. And what about 2 pi r, where r represents what? Radius. Very good. Those are the exact same formula. Does anyone know why? Yep. Very good. If you multiply the radius by 2, you're just dealing with the diameter. So guys, you only need to know one of them, right? And you can automatically get the other, okay? So pi times the diameter is the circumference, or 2 pi r, which is 2 times the radius, times pi, okay? Now, pi is a symbol. How many of us have seen the symbol pi before? Okay, if you have not, okay, pi is a ratio that we use for these circles, okay, and it helps us figure out the circumference of a circle. It's a number, okay, but it is irrational. Now, an irrational number is a number that's non-repeating, so it doesn't repeat itself, and it's also non-terminating. That means it is a decimal that will never end. Nobody knows the end of pi, okay, but you can get as far as you want, but nobody actually knows the very end of pi, okay? And irrational means you cannot write it as a fraction either, okay? Now, I want us to take out our calculator, so if you have your calculator with you, please take it out at this time, okay? Pi, for our sakes, is either going to be, you're going to have 3 possibilities for your answer. Your answer could say, okay, I want you to leave it in terms of pi. That means that pi will be part of your answer. They're going to tell you, okay, approximate pi using 3.14, which means that anytime you see the pi symbol, you're going to approximate it with 3.14, or it's going to say, I want the exact value of this answer, which means that you're going to use the pi symbol from your calculator, okay? Now, on your calculator, I want you to locate the pi symbol at this time. Oh, and I need light for this. Then you would not use the pi symbol. You would physically type in 3.14 wherever you see pi in your equation, okay? Those are 2 different scenarios, okay? So the value of pi in your calculator is a non-repeating decimal. It goes as far as pi is. But when it asks you to plug in 3.14, you have to chop off at 1/4 and not use the pi symbol. Are we clear on that? Okay, so let's check out before our first example, let's talk about arc length. So arc length is a portion of the circumference of a circle. It's not the full thing, it's just a piece of the circle. And you can use the measure of an arc in degrees to find its actual arc length in linear units. For example, inches, meters, feet. Arc length in a circle is the ratio of the length of a given arc to the circumference, and it's equal to the ratio of the measure of the arc to 360 degrees. So the formula, and the one that I want you to box in, is this one on the right-hand side. The reason that there's 2 here is to show you where this formula came from, okay? So this formula comes from taking the length of an arc, for example, AB, divided by the whole length of the entire circle. Do you guys agree that the entire length of the circle is 2 pi r? That's our circumference. We can put a C there. Do you guys agree that that's the same as circumference, 2 pi r? Hello?
Yes.
Yes.
2 pi r?
2 pi r is the circumference, right? And circumference is the distance all the way around the circle, correct? Correct. No, that's 360 degrees. That's different. Circumference is the distance around the circle. So like it's 360 degrees, but how many inches did you move? Right? So degrees is different. Degrees is an angle, right? Degrees isn't like a physical measure of like, if I told you I walked 5 degrees right now, what would that mean? You wouldn't know, right? But if I told you I walked 5 feet, you would have an idea of what I'm walking, correct? If I told you you're 5 feet tall, that makes sense. Would you know how tall you are if I said you are 5 degrees? So length is different than measure, right? Measure is like the degrees in terms of a circle, like how many degrees did we turn to get to this spot on the circle? The length is different. So how long, far did you travel, okay? So how we use this formula, okay, is we say the measure of the arc divided by 360. So the measure of the arc out of the whole thing, and then you multiply it by the circumference formula, which is 2 pi r. And you will see me a lot substitute for 2 pi r the letter C, which represents circumference, okay? Because remember, if you take your circumference and you multiply it by the ratio of the degrees over 360, that will give you the arc length. It's a portion of the entire circle. Okay, I will. So let's say AB, we knew it was 60 degrees, right? That means that arc is 60 degrees out of how many degrees in the circle? 360. So to find the portion that arc is of the entire circle, we would do 360 in the denominator and 60 in the numerator. Do you agree? That ratio, what we're doing with that is we're multiplying it by the circumference. Because then that's telling us, okay, circumference is the distance all the way around the circle. Do you agree? So if I started at B and I go all the way around the circle and I end up back at B, this is circumference. You're taking that circumference and you're multiplying it by a ratio, which is 60 over 360 times your circumference, which gives you just that part in the red. Do you see that? It'll only give you this part right here, and it won't tell you the length of the entire thing. Christian? You'll have to figure it out. So it'll give you the radius so you can find it.
Find the circumference first.
Mm-hmm. And then multiply it by the ratio. Yeah, go ahead. Set a timer, please. What other questions do we have so far? Okay, I promise it'll make a little bit more sense when we do some examples. So let's take a look at example 1. It says find the circumference of a circle with a diameter of 5 inches and leave your answer in terms of pi and then use 3.14 for pi. So we're going to have 2 answers here. We're going to leave it in terms of pi and we're going to use 3.14 for pi. We are not going to use the calculator stored value of pi. So circumference of a circle with diameter. What is the formula for circumference that also involves diameter? Nick? C equals pi times diameter. Very good. So C equals pi times diameter. And what is the diameter for this problem? D equals 5. So we're going to take 5 and plug it in for D. So C is equal to pi times 5. So if we're going to leave this in terms of pi, make sure the numerical portion comes first. C is equal to 5 pi. That's it.
That's the answer.
That's the answer in terms of pi. Now the second part of the answer was it says it wants you to use 3.14 for pi. So let's substitute it in. We're going to say that circumference is also equal to 5 times, what am I substituting for pi? 3.14. And in your calculator, you have to physically type this one in there. You cannot use the pi symbol because the pi symbol will use the entire value of pi, and you just want to use 3.14. Multiply 5 times 3.14. What do you get?
15.7.
15.7 is correct. I'm missing one thing on both of my answers. What am I missing? What? Not degrees. What? Yes, it's units. What units does it need? Inches. Very good. Inches here. We're going to put IN and inches here. Because remember, circumference is not degrees. It's not the measure of the arcs. Yes?
So if it's asking you to use pi, make it equals
No. In terms of pi would be the red answer, 5 pi inches. Okay?
if it doesn't, if it doesn't say leave your answer in terms of pi, then we do that.
No. If it didn't say in terms of pi or use 3.14 for pi, you would use the pi button on your calculator.
So if it doesn't say either of those two, just use pi.
So go ahead and multiply 5 times the pi button on your calculator, and you should get a different answer. Go ahead, Kristen. All right. Part B says find the radius of a circle with a circumference of 17 pi feet. So now we're starting with the circumference. We now have to find the radius. What's the radius formula for circumference? C equals what? Pi r squared? No, that's area. 2 pi r. Very good. Okay. And we know which of these values? We know C. C is 17 pi. So plug in 17 pi for C. We're going to get 2 pi r. So 17 pi equals 2 pi r. And we're asked to solve for the radius. We want to find the radius. So this is now just becomes an algebra equation. Remember, pi is just a number, so you can treat it like a number. How could I solve for r here? Daniel?
Isolate the r, so divide by 2 pi.
Excellent. Divide by 2 pi. What do you get?
17 pi over 2 pi.
Yeah, 17 pi over 2 pi. Because these 2 pi's are going to cancel. We're going to get r equals... Guys, what happens on the left side? What's 17 pi over 2 pi? Does anything cancel out? The pi's cancel out. So now you just have 17 divided by 2.
2 pi or just 2? Oh, the pi's cancel out.
Did you get 8.5? 8.5. What am I missing? Very good. Feet. You have to add in the feet here. So our radius is 8.5 feet. What's the diameter of this circle? 17. Very good. How do you get from the radius to the diameter? You multiply it by 2. Okay? And you can do vice versa. So if you found the diameter, you could just take that diameter and divide it by 2. Okay? German, can you in your calculator plug in 17 pi divided by 2 pi and see if you get the same answer? And you guys try it as well. 17 with the pi symbol divided by 2 pi. You did not? You got 83.9? Okay, this is a very common mistake. Let me show you on your calculators why this. 2 more examples. These examples involve arc length, okay? So we're going to talk about arc length. It wants us to find the indicated measure of the arc. So we're going to find the arc length of AB. Let's remember the formula. So it says length of AB, the arc, is going to be equal to the measure of the arc AB over 360. That's the measure of the whole circle. The circumference. Very good. Let's put C here. Daniel, go ahead. That's an arc AB, yeah. Okay. Do we know the length of AB? No, we're trying to find it. So that's going to remain as our variable. So we're just going to leave it as length of the arc AB equals. Do we know the measure in degrees of the arc AB? It's 60 degrees. How do you know it's 60 degrees? That's not the measure of the arc. That's the measure of the angle. APB. Why would these have to be the same?
Because it's coming from the center.
What would you say? It's a central angle. Thank you, German. Okay? It is a central angle. So it must also be 60 degrees here. So it's 60 over 360 times, what formula do you want to use for circumference? 2 pi r. Why 2 pi r? It gave us a radius, right? It gave us 8. So let's use 2 pi r here. And instead of r, I'm going to substitute it in the 8 centimeters that it was. Yep, that's 2 pi r. All right, so now in your calculator, you're going to use the pi symbol. I want you to do 60 divided by 360, multiplied by 2 pi, and also times 8. What'd you get, Christian? 8.4 if you round it to the 10th. I think I got that too.
8.34.
Can anyone confirm that? German, you're good? Okay, what units does this guy need? Centimeters. Hey now, can I explain what we just found? We knew at the start that the measure of this arc, the measure of it in degrees was how much? How much? How many degrees with that arc, the red arc? 60 degrees. But now I just found the length of it, which is different than the degrees, the length of it, if you were a human walking along this arc, the distance you would have to travel is 8.4 centimeters. 8.4 centimeters. Talk to me. What questions do we have on this first example? Cody?
So 2 pi r, use the 2 pi r since it gives you 8 centimeters.
Correct, because it gave us a radius, not a diameter. I mean, you could technically, if it gave you the radius, just multiply it by 2 and use 16 pi. It's not hard, right? So you can use either one that you want. I'm just going to use whichever value is given to me, okay? Good question. What other questions do we have? Okay, let's check out B. In letter B, it wants us to find the circumference of the circle Z. All right? But it gives us the arc length and it gives us the measure of the arc. So let's set up the exact same formula. It's going to be the length of what arc? XY equals the measure of that same arc XY over what? 360 degrees times what? 2 pi r. Instead of 2 pi r, let's use C. What are we trying to solve for? Circumference. So do you guys agree that if I leave this as C, as long as I solve for C, I'm going to be fine? So it's advantageous to leave it as C and not to leave it as 2 pi r. So let's find the length of XY. We know what the length of XY is. What is it? 4.19 inches. Very good. Equals, what's the measure of the angle? 40 degrees over 360 degrees times our circumference, C. Remember now, we're solving for this variable, C. What can I do to both sides of the equation to solve for the variable of C, to isolate it? Multiply by what?
360.
Multiply by 360? Only? Over 40. What do we call that? The reciprocal. Very good. We multiply by the reciprocal so that the 360s cancel, the 40s cancel, and we do it to the other side. Multiply by 360 over 40. So now in your calculator, you're going to multiply 4.19 times 360 and then divide it by 40. 37.71. Let's round it to 37.7. Let's put inches and we're done. German, can you confirm the 37.7? Thank you. In a calculator? Huh?
4.94.
Yep. Take 4.19, multiply by 360, and then divide it by 40. Okay? What questions do we have on this example? Okay, letter C. The measure of the arc RS. Let's be very careful here. How many letters did it use to identify the arc RS? 2. That means it has to be what kind of arc? Minor. Is it talking about the top half of RS? Or the bottom half? Why the blue one? It's smaller than 180. Very good. Keep that in mind, guys. The notation absolutely matters. So if we're finding the length of RS, we're going to put length of RS, the arc. It's equal to what? What's the formula? Yep. The measure of RS divided by 360 times C. Okay? Very good. And in this case, guys, we are looking for the measure of RS in this case. So we're going to have to solve for this variable. Okay? Do we know the length of RS? What is it? 44. So let's plug that in. It's going to be 44 equals the measure of RS over 360 times, do we know the circumference? We can know it. How? We have the radius. Very good. What is the measure of the radius? 15.28. So what is the formula for circumference in terms of radius? 2 pi times the radius. Very good. And in this case, we know the radius was 15 point, what was the other? 28? 28. Now, guys, I'm confident that a lot of us can get to this stage. But what I'm starting to think is that a lot of us are going to struggle with solving for that variable, RS, the measure of RS. And it's specifically using these values in our calculator. So what I want us to think about is you're going to have to divide and multiply. So this value, the measure of RS, is our variable that we're solving for. What can I do so that I can isolate it? What can I do so that I can isolate it? I definitely need to multiply both sides by 360. Very good. If I multiply both sides by 360, that 360 in the denominator is now poof, gone. What else do I need to do to isolate the measure of RS? Divide by what? 2 pi times 15.28. These go away. 2 pi times 15.28. Now, guys, I want you to plug it into your calculator, but I want you to make sure that your denominator, what did we say in the calculator it needs to have around it? Parentheses. So you're going to do 360 times 44 divided by, open up your parentheses, put 2 pi times 15.28, close your parentheses. Dylan, what's up? You got it? What'd you get? 165 degrees? I believe that's correct. The measure of RS should be 165 degrees, approximately. But let's put 0.0. Because did you round it to the 10th? It should have been like 0.98 something, right?
Yeah.
164.98. So if we rounded it to the 10th, it would round that 9 up, so it'd be 165.0. German, you got the same thing? Okay. Talk to me. What questions do we have? Hannah. How do I remember all of it? It's really only 2 formulas, Hannah, okay? You need to know the circumference formula, which is 2 pi r. And you need to know the arc length formula, which is the measure of the arc over 360 times the circumference. Okay? Yes, Sophia. Yes. So you should have plugged in 360 times 44 divided by, make sure you have parentheses, Sophia, around 2 pi times 15.28. Let me know if you get the 165. You did? Yay. Okay. 0.98. Perfect. Go ahead. What else? We're going to take our time with this lesson, guys. It's very, very important. We're Gucci? All right, moving on. More examples. Example 2, find the diameter of a circle with a circumference of 16 feet. Use a calculator and round to the nearest hundredth. Did it tell us to leave our answer in terms of pi? Did it tell us to use 3.14 for pi? So what are we going to use for pi? The calculator pi, okay? We're going to use the calculator pi. So let's set it up. What's the circumference formula involving diameter? What? Pi times d. C equals pi times d. And what piece of information did they give us? What is 16 feet? The circumference. So we're going to say C equals 16 feet. We plug that into our formula, so plug it in, guys. You're going to get 16 equals pi times your diameter. What are we solving for here? Your diameter. Very good, your d. How do I solve for d? Divide by pi. Divide by pi. So in your calculator, what are you going to plug in? 16 divided by, and then use the expression for pi. German? Huh? 5.09 feet. Why did German round to the nearest hundredth and not the tenth here? It says round to the nearest hundredth, okay? If it does not say to round, what are we going to round to? The nearest tenth, okay? But if it says specifically what to round to, you have to understand to round to that. Questions? Talk to me. All right, how would you find the radius? Divide 5.09 by 2. Remember, 2r is equal to your diameter. So if you get the diameter, divide by 2. If you get the radius, multiply by 2, you've got the diameter, okay? All right, part B says a car tire has a diameter of 28 inches. How many revolutions does the tire make while traveling 500 feet? Use a calculator and round to the nearest tenth. I am going to draw a picture because I'm a picture person. So draw a car tire. You can probably draw better than one than I will. Give it some rims. And then draw a diameter through that car tire. What did it say the length of the diameter was? 28 inches. And then it wants to travel 500 feet. So we're going to draw a length of space. It wants to travel all 500 feet. Okay? So it's asking how many times would this tire, right, have to, like, how many revolutions would it go through in order to get to the end for 500 feet, right? So we need to know how much would one revolution be? How far would it travel in one revolution? So if you start here and you revolve all the way around the tire, what is that distance?
If you do 1 360.
What?
If you do 1 360.
Yeah, so a whole 360 degrees, right? But remember, we're not going to measure this in degrees because degrees and feet, right, they're different units. So what could we find about this circle that would help us with this problem?
28 divided by 360.
No. The radius. What is the radius here? 14 inches, right? Hannah? Oh, you're just stretching? Do you guys see the blue arrow that I drew around the circle?
Yeah.
What represents that? The circumference. So do you guys agree if a tire rotates, it's full all the way around, it's gone one circumference? It's traveled around one full time? And it's also traveled that distance on the ground because it rotated that amount of, that length around on the ground, correct? So if our car rotates that distance, as long as we find the circumference, we're going to find how much it travels in one revolution, okay? So circumference equals 1 revolution. Before we start calculating the circumference, guys, these were not given in the same units. One was given in inches and the other one was given in feet. You only have to convert one of them. Which one would you like to convert? Inches to feet? Okay. So change this 28 into feet. How do we change a 28 inches into feet? Divide it by 12 because there's 12 inches in a foot. So you would do 28. Go ahead and plug it into your calculator. 28 divided by 12. What does that give me? 2.3. 2.3 what? Repeating. And then that is feet. Okay, so now let's use our circumference formula. So our circumference formula is pi times the diameter. In this case, it's going to be pi times 2.3 repeating. So in your calculator, make sure you use the 2.3 repeating and you don't round that number. So if you have to plug it in again, it was 28 divided by 12, and then multiply that by pi. 7.2? German? 7.2? Feet. Yep.
I didn't get 7.2.
What did you get?
7.3.
Did you use 2.3 or 2.3 repeating?
I did 28 divided by 12 times pi.
Okay, that line on top of the 3 just means it's a repeating decimal. So this is like 2.33333, and it goes on forever, right? That's what that line means. Yes. You leave the answer stored. So if you need to type it in again, just do 28 divided by 12, and you'll get that exact answer stored again, and then just multiply that by pi. Okay, so now we found out how long it takes for one revolution, right? It's 7.3 feet. How do we find out the number of revolutions it'll take to reach the full distance? Cody? Divide what? Very good. Divide the 500 by the circumference, and that'll give you the number of revolutions. So if you do 500 divided by that 7.3, 68.5, 68.5 revolutions. All right, this is where we're going to stop for today, guys.